All right, perfect.
Okay, fantastic. So can everyone see my screen okay?
Yes, we can.
Okay, perfect. So good afternoon, everyone. And I will take just a few seconds to introduce myself here. So I am Matilde D'Arpino, and as you may hear from my accent, I come from Italy. I have done all my study as an electrical engineer in the University of Cassino in southern Lazio. It's a city very close to Rome, and that is where I grew up, and then when I did all my study, and I became an electrical engineer there. I did my PhD back in Italy as well. And after that, I joined Ohio State as a visiting researcher for like a short time, around 6 to 9 months, and that happened 7 years ago. And since then, I'm still at OSU. So I got in love with OSU, and actually I got engaged with several of the research activity that were happening at the time at the Center for Automotive Research. That is where I started to work. And then from a researcher, I recently moved to a professor position. And I am now a research assistant professor in the Department of Mechanical and Aerospace Engineering. And I also have a joint appointment in the Department of Electrical and Computer Engineering. So this has been my story here. And there are a few pictures about myself. I thought, before going into some more technical aspect and telling you a little bit more about the story of and showing a little bit about our labs and things. So this is actually the project that brought me to OSU. And this is me working on a kind of crazy vehicle that we will see we will learn a little bit about it in the next slides. But this is currently the world's fastest electric car, and is built and developed completely by students at OSU in collaboration with some of the researcher and professor, of course. But a few years ago, we achieved a world record as the world's fastest electric car, 341 miles per hour. So this is, if you drive your car, you understand what that means. That's pretty impressive. Is still the record has not been broken yet, so we are very proud of being able to develop technology that would support students, but on the other side to demonstrate that electric vehicle can be cool and powerful. And here you see me with conferences or with some of our students and the researcher when we work in the lab. So I understand that all of you are probably from the area of Columbus or so. And so I don't need to tell you about the Ohio State University, but this is one of the largest university in the United States, and it includes both the number of students and also the kind of research that we do here. And I specifically have been working and growing my research into the Center for Automotive Research. That is one of the centers within the Ohio State University. And as you can understand from the name, we work on automotive. And an important thing that we need to mention is that automotive, especially right now, is not a very focused topic, but it's very broad. There are aspects that concern mechanical engineering, aspects that concern electrical engineering and computer, but then we have a lot of other aspects related to business. How we make this vehicle profitable, as an example, and how we develop infrastructure to support, future electrified vehicles. And then there are a lot of aspects also related to interaction with the humans. So how we are able to make sure that these novel vehicle are approved and proper design to support the needs of the people that will be using the vehicles. And this concerns many different aspects that are some more technical, but some of those are also more practical, you know, being able that to make sure that we are able to charge the vehicle, that they're accessible to everyone as well. So at the Center for Automotive Research, we focus on many different topics, but we try to be, you know, summarize a little bit with these two sentences over here. We are looking at making the vehicle clean and efficient. And how we do this, there are, of course, many different approaches, but one of the things that we have been working on in the last 20 years or so is to work on making the vehicle electric or electrified, so including some kind of battery, electric machine, and other things that can support the propulsion, so the movement of the wheels, and to try to reduce CO2 emissions and improve also efficiency. You know, we are living in a world in which we use electricity for a lot of things. And while we have the capability of producing more electricity, we need to make sure that the one that we have available, we use it efficiently without too many losses. And we do the proper work that electricity is designed for. And the other aspect is safety and security and intelligence of these vehicles. And you understand that, you know, we are now, you know, we have around us millions of vehicles that have an engine inside, and we are very confident. Every day we sit on one of our car and there is so much fuel in the car that can correspond to a bomb. But we sit in the car, we go to point A to point B, we use this vehicle to transport kids and other kind of, critical components, and we feel good. And because we have been developing technology for traditional engine-based car that are safe and secure. And so we feel safe even if we have so much fuel on board of a traditional vehicle. Now, when we talk about battery, we see on the news that as soon as there is an accident, the news go crazy related to battery, and especially lithium-ion battery have critical material inside that can be dangerous, let's say, because they can self-ignite if not properly controlled. And so we need to make this vehicle as safe and get the people confident as well as we are confident of traditional combustion engine. Because when in both kind of vehicles, we have a lot of energy on board, that what I say to my students, you know, you're working with a small bomb. In any case, if it's fuel or if it's a battery, it's the same thing. So our work here and our commitment is to make this vehicle safe and secure. And the other aspect that you may be hearing a lot is talking about autonomous vehicle. So having the vehicle driving themselves. And this is kind of course, a challenging topic to discuss. And we do some work in this area. This is not really my field of research, but we do work in this area, and OSU has been working on this topic for many, many years. As a matter of fact, OSU has been one of the first to put a computer inside a car, and that happened many, many years ago. So we are part of the history in looking at autonomy of the vehicles, but there are a lot of challenges. So we will not see autonomous vehicle right away, but this will come, you know, later on in the development. But the main scope to make them autonomous is to reduce risk of accident, but also to improve efficiency, because vehicles that have knowledge on the future and knowledge of, the traffic light positions and other things can actually help us to improve efficiency, because if a traffic light is going to turn red, there is no need for us to accelerate, correct? We can just coast down and get to the traffic light and not waste energy. So these are some of the things that we can work on and improve the technology by utilizing this new, let's say, concept of autonomous and connected vehicles. So our mission at CAR, at the Center for Automotive Research, is practically related to three aspects. One is education. The first thing that we do is that we build the workforce of the next generation of automotive industry leaders. So our main outcome of what we do is, to train students, and this could be undergraduate students, master students, and PhD students that are interested in the automotive world. So they do projects with us, and they work on their classes, and they have also some extracurriculum activity that they can do at our center as well. And then we work in innovation. So we help the industry and the federal agency solve some of the problems or the roadblocks that we have in some of these technology. So electrified vehicles and connected and autonomous vehicles, as an example. And then we support the economic development of the region and the nation. So we work with the industry very closely and supporting them in something that we call engineering services. And so we provide them with the tools that could be our labs or our engineers to support their product development and in many different ways. So here there are a few numbers. I won't bother you too much with this, but I want to say just that our center within OSU is actually a decently large enterprise. So we have like 90 faculties, professors like me and others that work with us, work with the center, as well as administrative and research staff that is there to support the research enterprise. And then our employees are actually the students. The students work with us to solve some of these, problems and challenges that we have. And more or less, this number goes up and down depending on many different things, but we have around 80 to 100 master and PhD students that work with us. And so they get tuition waivers and a stipend by working with us and contributing to the mission of the center. So as I was mentioning before, we work with the industry and with federal agency, and also work with the state. And as you can imagine by the news and everything, the topic of electrification is exploding. And so also from our side, the request of and the opportunity to do research in this topic is exploding as well. In the last 5 years, we have seen 50% increase in funding opportunities. And we are not the only center within OSU, but actually there is a multitude of centers, and we collaborate very strictly with many of those. This is just to show you a little bit a picture of our different capabilities. And who are our sponsors from the federal and industrial side? As you see, you may recognize many of these names, and there are some that are very, clear, GM, Ford, Stellantis, that was the old Fiat Chrysler. All of these are very, it's what you would expect. And the Department of Energy, Department of Transportation. But we do a lot of research with NASA as well, and the Air Force. And I will explain why in some of the next slide. And of course, Honda and Cummins, I won't forget about them as well. So what is my research in all of this background? And this is one slide, it's very full, sorry for that. Next slide will be a little bit lighter. But my research is actually related to energy storage system and batteries. Batteries are now everywhere. You are probably wearing some of them right now in your phone or your watch or other things. But in my research, I look especially on battery from the mobility point of view. And as you see in this small graph over here, I hope you can see my mouse. Battery are now in the passenger car and, in electric vehicles, as an example. They are we are talking about having electrified aviation as well. So aircraft that would not be propulsed by jet, but by jet fuel, but they could be propulsed by batteries, lithium-ion batteries as well. there are a lot of talk and a lot of work that is going on now in transit and commercial vehicle as well. So electric buses and commercial vehicle to transport goods between point A and point B. So I do a lot of activity in the field of battery, and this goes from testing batteries into the lab, and this is what you see here in the picture, developing a mathematical representation of the batteries, and then actually developing prototypes. We have capability of developing battery packs inside car, and from that, we use this technology to do tests, to deliver to companies and all other kind of things. And another important aspect here that I want to mention is one of the most important thing that we study about battery on top of safety is also aging. As we know, every one of us age, and the battery are actually very, very similar to humans. They age if they are doing things at high temperature or at low temperature, and they age even if they are not doing things. So if you have a battery that is on a shelf, the battery will age even if it's not used. So we develop all of this kind of characterization because battery are a recently new component in our, let's say, technology. The people that have invented the lithium-ion battery received the Nobel Prize a few years ago. So lithium-ion battery is not a very old technology. WISE has gone very deeply in all our life, in this use nowadays in many, many different things. We don't know a lot about them. So we are studying to actually understand what happens in the cells when they are used, and how we can make sure that we can predict and we can design system properly, that they don't fail, and also that they make all the business model working, because at the end of the day, what everyone cares is money. So after this introduction here about car, the center, and the research that we do, I want to provide a little bit of background about electrification and why we do electric vehicles, and which are the main opportunities and challenges that we have for these electric vehicles. So everyone understands energy. Energy is the ability to do work. And here there are some examples. Some of those are funny as well. And in this case, we are looking, the energy or the capability of a person to do work. But we have also object, that can do work. Like a vehicle that moves on a road is doing a work, is transporting a person or a good somewhere. And then, there are roller coaster here. There are some other, electric instrument that do work. And what my research focuses especially, object that to work in this area. So we're talking about car, so ground transportation, air transportation, renewable energy, and batteries. So all of these are important topics today that are actually enablers to create a more sustainable environment for us, and is concerned from the energy production and also to mobility, so how we move people. And here what I've done, since battery is my research field here, I wanted to briefly describe what a battery is. And without going into the chemistry of the thing, a battery at the end of the day is several elements connected together. And what happens is that when you put several materials together, there are some chemical reaction that happens. And this is what we leverage when we do a battery. So that chemical reaction that happens, like when you mix like your water with coffee, there is a chemical reaction happening there, and that's what makes your coffee, and from the coffee powder. And the battery is actually, some other kind of material put together, and at a certain point, some chemical reactions start to happen, and this is what makes us, producing electricity. And of course, bigger the battery, bigger the electricity that we can produce. And one thing on batteries that we need to understand is that every time that we have a battery, is often several batteries put together. From the chemical perspective, we can build batteries that are around 3 volts, let's say, as voltage. To make bigger battery, what we do, we cannot make a battery, that is just bigger in size. The only thing that we can do is actually connecting more battery together. As an example, every one of you may be familiar with a Tesla. A Tesla has 7,000 lithium-ion battery inside. So 7,000 battery connected together. That's a large amount of things to control. Other vehicle may have more or less, depending on specific technology, but this is just to give you an order of magnitude. Like a computer may have 4 to 6 to 8 lithium-ion battery inside, but a vehicle has many, many more. So you understand that there are many challenges related to how to keep this battery cool, how to organize them, how to control them, and so on. And this is what we do with some of the research that I have been carrying out. So why electric? The main drive of doing electric vehicle is trying to reduce pollution. But it's important to understand that electric vehicles reduce pollution locally. What that means. Electric vehicles do not produce pollution where they are used, but to produce the electricity that you need to charge your battery, somewhere in the country, someone is burning coal or using natural gas. So the fact that the electric vehicles are, let's say, more that are reducing emission needs to be considered on a very larger scale, because locally, the electric vehicle does not have a tailpipe, so we don't produce CO2 or other kind of emission that are dangerous for our country or in general for us. But at the same time, somewhere else, the electricity needs to be produced, and that electricity, depending on how that electricity is produced, can be, reducing or not our overall CO2 emissions in a broader picture. So here there are a few examples of electric vehicles, and there are some more smaller size vehicles, and then here there is a Tesla, and then there is our world fastest electric vehicle, the Venturi Vaca Bullet, that I hope that if I have time we can see a little bit more about this vehicle. And this is of course not designed for road transportation, is more a special application vehicle, but I wanted just to mention that, vehicles have different, the electric vehicles are designed to support different kind of requirement. And there are several advantages and disadvantages of every technology. And we many times focus on here something happened, sorry. Those are inverted by any reason. Those are the disadvantages and those are the advantages. Sorry for that. But we focus very heavily often on the disadvantage of a technology, while I wanted to point out also the advantage of this technology. So let's go to the disadvantage first. And as I mentioned, here they are inverted, but disadvantage is that there is a lack nowadays in charging stations. So people get let's say, quite overwhelmed when buy electric vehicles, because they say, where the heck am I going to charge? And we can charge at home for sure, and that's an advantage, because potentially with electric vehicle, if you do so many miles per day, you actually do not need to go to the gas station anymore. You can charge at home overnight, and this is for sure an amazing advantage of electric vehicle. But sometimes, either you need to do a longer trip, or you are a commercial vehicle that needs to do many, many stops over a day and consume a lot of electricity. So we need a charging station infrastructure. And the Department of Energy, Department of Transportation, and many other entities are actually investing a lot in building our charging station infrastructure, but it's not there yet. And the other thing is that we are used now to go to the gas station, and in 5 minutes, maybe less, we are able to refuel our tank, and that corresponds to 300, 400, 500 miles of range that we cannot do the same with battery at the moment. the current battery technology that we have, it has slower charger capability, so we cannot charge them as quickly. And this is because of some safety issue. So we don't want to charge the battery too quickly because they will degrade and they will not keep their performance over time in the same manner. And also because potentially you can have a fire hazard. It's what we call thermal runaway. So we don't want that to happen, of course. So in general, with electric vehicle, we have seen that the vehicle may have a shorter range. Things are for sure getting better, but the other important aspect to consider is the initial cost. So there is a bigger, let's say, ticket price when you buy the vehicle, but then your operational cost, that is practically your refueling, is very low. Electricity is much cheaper than fuel. So over the long run, you will have some benefits, but at the start, your electric vehicle will cost more. And this cost is actually mainly due to battery. But let's go back to the advantage. So the first thing that we said is that you can charge at home. So potentially you don't need to go to your gas station in the future. And that's, you have also zero emission in loco, so on the site in which the battery is used. I was talking with a friend the other day, and she was mentioning that she bought a Tesla, good for her, for sure. And she bought it because she was tired of smelling gas in her house after parking the car. So I never thought about that, to be honest, from my side, but that was her, let's say, justification of why she bought a Tesla. But there are others. The other one is high energy efficiency. So we are actually able to lose less energy with an electric vehicle compared to a traditional combustion engine vehicle. As an example, the efficiency of an engine is around 35 to 40%. It means that 60% of the energy is lost. So that's a big waste. While with electric vehicle, we are around 80% of efficiency. So only 20% of the energy is lost. So this is why on the overall business model, there is a lot of push for going with electric vehicle, because we are able to use energy in a more effective way. The other thing that I wanted to mention here is that when we talk about electric vehicle, can actually get very complicated because there are many different options. And I could have, many slides to describe this, but I wanted just to focus on a couple of them. And we talk about battery electric vehicles, that is a full electric vehicle in which there is no engine anymore. So we have a battery and an electric machine that is actually moving your wheels. It's a very, very simple vehicle from the number of components perspective. However, one of the main limitations of these vehicles is that we need a lot of batteries, so a lot of weight and also a lot of cost. And this is why a Tesla, that is a BEV, a battery electric vehicle, is expensive, because there are so many batteries. Consider that all the base of the vehicle is including those 7,000 batteries. And also it's expensive when you may need to replace in the future the battery. But over long run, you will not have to buy fuel, and you pay electricity 10 cents per kilowatt hour. And so it's a pretty good deal over the long run, for sure. On the other side, we have the plug-in or hybrid electric vehicle. Just to be more concrete here, the Toyota Prius is a beautiful example. And the Toyota Prius is now, I think, more than 20 years old. And there have been, of course, several models. But in that case, you have both the engine and the battery in the same chassis of the vehicle. And what happens is that you decide when to use the energy from the gas or from the fuel and the energy from the battery, depending on what is more convenient at that time, or they work together. And so there is a controller there that decides, okay, at this time, I may need energy from fuel. At this time, I need energy from battery, depending on what is more economically convenient at that specific time. And these vehicles are not as, let's say, efficient as the battery electric vehicle, but for sure they allow you to have higher range because you still have some fuel on board. So many, let's say, people are considering hybrid electric vehicle also because it's a technology of transition. In the future, possibly we will have only or more and more battery electric vehicles, but in the meantime, it is, let's say, very simple for some of us to move to a hybrid electric vehicle that is also, the cost is more modest compared to a battery electric vehicle. So a thing that I want to mention is also that we have talked about ground transportation, but electric vehicles are not adopted only in ground transportation. We are actually seeing interest and possible business opportunities in many, many fields. And here from this picture here, you can see some example, but there are electric boats that are being designed, and in Europe there are already some application, and there are electric aircraft or drones or air vehicle that are also being designed as electric. And then on the ground transportation, of course, we have passenger car, motorcycle, buses and truck, and also some military vehicle. And I want to mention, I'm not really a fan of this picture, but I thought it was nice to show the overall background, because this picture shows this vehicle as very futuristic design. But as you have seen, electric vehicle can be, we have so many now around us that we don't know, because just they look like the others, just that we cannot see the difference from, the user perspective sometimes. So this is another maybe full slide, but what I wanted to mention is that the battery are actually the heart of the electric vehicle. So as in a combustion engine car, the engine is where the research and the development has happened for years and years to make them more efficient. When we look to an electric vehicle, what is important is actually how good is the battery. The other technology, there is work that is being done in electric machine and other controllers and so on, but they are already at a very good stage. What we are doing now in this other technology is mainly to reduce cost and to make them more reliable. For battery, we are really at the start of this technology. As I was mentioning before, there is so much to do. And this is why you see so many investment in this area. And it's very overwhelming sometimes, for me at least, to work in this field, because every 3 or 4 days, you see that there is a new announcement. We created the new battery that are going to solve all the problems. And they publish, on the newspaper and everything. And then a few days later, you discover that that was not the case. So there is a lot of, let's say, confusion and worry about, and let's say people are trying to scramble to try to develop this new technology, but those are things that happens over time. So when you see some of these new announcements, take them with a grain of salt. Many of these new technology will take years and years before they get available to us. So what I'm saying is that lithium-ion battery is what we have today, but in the meantime, we are developing other chemistries that are based on other kind of metals, other kind of materials that potentially provide us, also help us to solve some of the issue that we see today, especially related to durability. So capability of battery to last for a long time and capability of the battery to be charged quickly. But all of this takes time. And the other important aspect that we are trying to solve is safety. Unfortunately, with lithium-ion battery, there will be always the possibility of failure that could be related to a fire hazard. We cannot eliminate that. So we are working on chemistry in the future that will avoid these, but will not be lithium-ion anymore, will be other kind of batteries. The other thing that I wanted to briefly discuss today is about charging. So there is a a big misconception from my side on the charging side. And so I use this opportunity to talk with you about this, and maybe you can talk with your friends. And I think this is how we create, community and knowledge about this. But charging for electric vehicle is not always a disadvantage. As I was mentioning before, with electric vehicle, you can charge at home. Here, there is the example, is what we call level 1 charging, without going too much in the nomenclature, but this is literally plugging your car in your wall. Requires a cable, the cable comes with the car. You plug it in, if you do 50, 100 miles per day, you have no problem. You will never go to the charging station in your life. When you may go to the charging station, maybe you're doing a long trip, you're going to South Carolina for a summer trip, and you may need to stop a few times on the way to charge your vehicle. And at that point, there are other options. And what we hear a lot now is DC fast charge, or supercharge, or extra charger. There are several nomenclature here, but those are higher charger capability that you will already see the box. Here we go from a tiny, tiny, small box that comes with your car with something that is installed on the side of the road. And those are really designed to provide you charge in a short time. And we're talking about less than 1 hour. Now, you are used to go to the charging station, to the refueling station, and charge your vehicle in 5 minutes. We are not there yet, but we are doing better. So like currently, let's say in 20 minutes, you could gain 60 to 80 miles. That I know is not very promising at the moment, but is, let's say, better than what was some years ago. But these charging stations are now getting more available. So I actually have a link here that I wanted to share very quickly. Let me see where this is. There are many websites that actually keep track of the charging station location here. And sorry, my computer is being a little bit funny at the moment. Okay, let's see. So there are many available, but practically what this website do is that they report all the charging station in the area. And this is Columbus. So I just type on the internet, charging station in Columbus. And these websites are becoming, oops, oh my goodness. I said that my computer is acting funny right now. Okay. Okay. So they report all the status of the charging station. They tell you the power, if they are busy or not, the company, the brand, and all kind of information. So step by step, let's say the infrastructure is building, but it's clear that as of now, these fast charging are not available everywhere or in every corner as it is for a gas station. But as you see from the number here in the area of Columbus, and what you see here is a larger than 270, you see that there are many opportunity in the city. And in the meantime, the Department of Energy also with Electrified America have been developing infrastructure also between big interstates. So those are getting more and more available as well. So going back here to the presentation, oops, oh my goodness. I want to mention that unfortunately, all the technology come with some drawbacks. And one of the things that we are studying related to charging is actually the impact of the charging on the grid. The grid is designed now to provide power to our homes, to the industry, and to large enterprise. It's not designed to provide power to every one of us recharging. So there are a few things that we can do, but what is expected now is that the power demand on the grid could increase by 30% when we will have more penetration of electric vehicles. So this higher power demand, of course, can cause issue over the long run because the grid is not designed for that. So part of my research is actually looking on how to mitigate the impact of the charging event on the grid. And this is especially coordinating things. So one of the beauty of the, let's say, research that we are doing nowadays is that we have data. Data are an amazing resource for us to optimize things. Because if I don't know which is your specific, let's say, timing in requiring charging, I cannot plan ahead. But with all the technology that we have today, the fact that we can coordinate vehicles and we can coordinate with you or with me on when I want to charge or when others are going to charge. I can coordinate with when the sun is available and there will be renewable energy available on the grid. So all of this capability of getting data and using technology like machine learning or artificial intelligence to actually learn from this data and develop algorithms that could coordinate things and avoid to have, high power demand on the grid. So this is some of the activity that we are doing. And the other aspect here that I want to briefly discuss is the battery life cycle. As we understood, the battery is the central components of electric vehicle. And you may have heard of all the effort that the federals are doing in trying to build an infrastructure to actually develop battery in-house, because currently a lot of the battery that we have come from Asia. So developing the battery is actually is not enough. We don't need to understand only how to make battery. We need to understand what happens to the battery when they are, not good for the specific application. And there is very little market now, but in the future, when there will be more and more electric vehicles, we expect to have a circular economy, and that's what we are working on. So here in this small cartoon here, you see the cell, that there is a way that we have to fabricate cells. And this is usually come from new material right now. And then we fabricate the battery pack and we use it in electric vehicles. You use the vehicle for 5 years, 10 years, 15 years, depending on how good you are with your battery. At a certain point, your battery will not be enough for your vehicle anymore. So you go to your dealer will take your battery, will give you a new one. Now, what do we do with the battery that we removed from your car? That battery was not suited for automotive and for transportation anymore because, you were not happy with the range. At the start, you were doing 200 miles. After 10 years, you are doing 100 miles. After 15 years, you are doing 50 miles. That's not enough for you anymore. So you go and you change your battery. You get a new one, you are happy. But at the same time, we have this battery that is kind of exhausted, but not fully exhausted. So what we do with them? We are looking actually to methodology to reuse this battery for different applications and potentially then recycle them. And the Department of Energy is actually investing quite a bit in finding way to recycle batteries. And it's not as easy as it is for plastic and other material, because in batteries, as mentioned many slides ago, we take materials and we put them together and they are very interconnected and they are very, very small. We're talking about micron, very, very small materials connected together. So then we have done all the effort to press these things together. And now we want to take them apart. That takes quite a bit of effort. So we are working on making sure that we can create this circular economy, because otherwise we will start to have a lot of waste. And this battery will end up to the landfill, and that's not what we want. Sustainable means not only sustainable at that time, but we need to create a cycle. So recycling needs to be part of it. And here there is an example of some of what we were mentioning here with a picture in my lab. So what you see here, this big column, this is a charging station. Can charge vehicle in 20, 30 minutes or so. Now it's off, but when you go, the screen is on. You can use your card to enable the charging, and if you have a vehicle, you plug in, and that's it. But in this charging station, I actually use I use renewable energy and other kind of storage to make sure that this charging station would not impact the grid. And so this test setup is especially designed to do research in this field and try to understand how we can mitigate the impact of the charging event on the grid. I think last comment here, and then I will show a video and I will look forward for your questions. One thing that we have been working quite a bit in the last 6 to 7 years now is also envisioning how we can apply some of the lessons learned in the automotive to aircraft and to commercial aviation. So you know that automotive is currently one of the first producer of CO2 emissions from the ground transportation, but then aviation is also one of the producer of CO2 emissions. So we are heavily working with NASA, Boeing, GE, and others in try to understand how we can integrate batteries and electric propulsions into aircraft. Be sure this is not something that you will see, in 3 years, 4 years, 5 years. This is more futuristic research, but we need to do this, as part of our mission as researchers. We are looking to the technology that is, let's say, shorter term, but also we are looking to more longer term research. And aviation is for sure interested in do their part in minimizing the global warming and making sure that from one side we still enable people to move from point A to point B, but at the same time we want to make sure that we do this efficiently. And the aviation industry has been always, utilizing the best technology, the most advanced technology, and they're trying to do the same also in this by looking at integrating battery and other components into the vehicle. And potentially in our study here, this was a hybrid aircraft. We were able to achieve more than 20% fuel burn reduction. So with all the technology that we put in the aircraft, if we were doing analysis over so many years for the vehicle's life, we were demonstrating that you can burn less fuel, and that corresponds, of course, to less CO2 emissions. So this was, let's say, a lot from my side, I imagine. But how long do we have? Because I do have a video and a few other comments. So, but I want also to have questions here. So we see what we can do.
Yeah, you're good with time. You're okay.
Okay, perfect. So what I want to briefly present is the students' activity that actually brought me to OSU as a researcher in the first place. So I'm honest here, when I started to work, or when I first heard about this project, I thought these American people were crazy. Because I was at a conference and there was Professor Rizzoni, that is the director of the center where I was working, was presenting about this Venturi bucket bullet tree and presenting the amazing technology that was behind that, but also was mentioning that this was a bunch of students, in the side of a building that were building this vehicle and trying to be the world's fastest electric car. And when you hear that for the first time, you kind of think that the person is a crazy person, consider that it's built by students. But actually, when I joined OSU and I started to work on this project, was just amazing to see the commitment of the student after hours, volunteer students putting their time and their effort in developing something that at the end of the day is now considered the world's fastest electric car. They had sponsor, of course. This is not a normal student project, with $5,000-$10,000 working on a vehicle. This project was heavily funded by elite car manufacturer in Europe that was very interested in contributing here. And so they provided the proper resource for the student to do this. So first of all, what the vehicle is. The vehicle is not a standard vehicle, it's what we call a streamline vehicle, has a special aerodynamic shape, as you see here, and it's called bullet for a reason. You can see from here. The aerodynamic shape is especially to try to go fast, and so to mitigate all the aerodynamic drag that you may have when the vehicle is going at this high speed. It's not a design for normal ground transportation. We would not expect anyone, going around with this 33 feet long vehicle, but it's a demonstrator to see which are the potential of electric vehicles, and was designed with a goal to go 400 miles per hour. And then COVID happened. So we reached only 341. So I think we did well. But there is for sure more that can be done on that side. So how this work? Where do we do this? So doing land speed records is not something that you can do everywhere for several reasons. One, for safety. Having a vehicle driving at that kind of speed is not allowed on the US roads. But also for space. You need a track of 6 to 10 miles to actually achieve that kind of speed. It's not something that is done, right away. It's not that you do 0 to 341 in 100 feet. You do that in miles. So the FIA, that is the who recognize this kind of records, is a French acronym, so I won't attempt to pronounce French, but those are, for these world records, there are specific standard requirements, and so they define exactly how you should do this record. And to be certified, there need to be people from FIA that are there doing the measurement, doing the acquisition, and all kind of things. But practically what happens is that in 1 hour, you need to demonstrate your speed twice in opposite direction. They do in opposite direction because you could have wind that is helping you in one direction. So then when you go in the opposite, you will have the wind in the opposite direction, because at this speed, everything counts. And then in 1 hour, you need to do this twice. The actual record is defined as the average over the true maximum speed that you have achieved. And when we are talking about a track of 6, 7, 10 miles, you can imagine that, it's not as easy to find something like this. So usually these kind of record attempts are performed in Utah, on the Salt Flats, close to Salt Lake City. So you see here the picture of the Salt Flats. Is a very nice, kind of smooth surface, and the people go there to challenge high speed. So they try to be the fastest in specific classes. And so OSU went there as well. And this is how it looks like. This is during Speed Week. It's an amazing event. Some of you may be familiar with it, but Speed Week happens in August every year, if COVID and weather allow. But what happens is that the Salt Flat becomes a racetrack. So you see here the racetrack, and all of these vehicles are in line to race. You go there and you try your best to achieve your best speed. And as I said, OSU has been there several times with the student team. And but if you go there, there are all kinds of vehicles. So as you see, there are vehicles that are similar to what you would see on the road, and have been, of course, modified. And there are people in their backyard that they develop this kind of thing. So there are professional teams as well. And they have different shape, different classes, depending on the engine, depending on the shape of the vehicle, depending on the weight. There are many, many classes. So it's not that you are competing against each other. You are competing against yourself at the end of the day to achieve that record. And those are the ones that go very, very fast, you know, in the 300, 400, 500 mile per hour range. Is they have this streamlined shape, and you see that the wheels are enclosed in the vehicle to have this kind of aerodynamic thing. And this is the craziest from my point of view. There is a person actually inside this car. The person is laying on his belly, and his face is kind of up here to be able to see. And you can imagine how dangerous are some of these things. If you go on YouTube, you know, your free time, and you try and, you know, write Bonneville accidents. I know it's not nice to see people having accidents, but it's also like crazy to think that someone puts itself in this vehicle and goes to try to attempt 400 miles per hour. But one of the most common accidents that happens with these tiny, tiny vehicles is the pencil effect. What happens is that, you know, you're going so fast that a small bump in the road or a small side wind can cause the vehicle to roll. And it will happen as a pencil. You know, if you roll a pencil, it will take time before it stops. And there are actually videos of this vehicle failing and, you know, starting to roll, and it's mind-blowing. This happens with very light vehicles. That's not our case. Our vehicle is very heavy, but, you know, there are all kinds of, this is a dangerous environment. When you go there, there are accidents happening. And that's why safety is a prime concern for us, for the student team. So here you see other vehicles. I think this one are even a special thing that I think those are a fuel tank from some aircraft from the Second World War that are modified. They put an engine inside and they go to race. So that's another crazy thing that you may see there. And then there are these kind of vehicles that are like jet, that they actually use jet from aircraft to race. And this kind of vehicle is trying to go 1,000 miles per hour. So you understand well, 1,000 miles per hour. So other crazy people. But it's, you know, when you go there, you actually get to see all of these vehicles together, all the technology that people have been building, and all the challenges that they have been experiencing. Is a fun event. So if you will have time in the future, going to Bonneville Salt Flat during the Speed Week is amazing if you are passionate about automotive. So here there are other examples. Motorcycles are also allowed, and here there is a track. So this is a track that was modified to be a Bonneville salt flat as well. And all of these vehicles are mainly based on combustion engine. But on our side, we wanted to bring, you know, an electric vehicle in the range as well. And what I was mentioning earlier is that there are different classes of record. And, you know, you go from lower than 100 miles per hour, and those are very special vehicles that are, let's say, sometimes kind of funny. And then you start to get, you know, more on the professional level with the vehicles that are attempting, you know, 100 miles per hour or 200 miles per hour, 300 miles per hour. You get very serious. 400, there is the Speed Demon that I think they have been going more than 400, like maybe 40, 50 times. So it's not only the world fastest electric the world fast electric, not electric, combustion engine vehicle, but it's also the vehicle that has been attempting more and more records. So the driver is one of the most experienced driver at this speed. Yes, and this is the turbinator as well. So there are many different things that you see there. And OSU has been going to Bonneville Salt Flat since 2004. So almost 20 years. And always with electric vehicles, and kind of being the first to attempt with electric vehicle. And you can imagine a bunch of students and a professor going there, and getting to interact with people that have been in racing for many, many years. The start was not easy to build a reputation in that kind of environment, but it has changed. So the fact that allowed us to go there many, many times, I think it says something. But in 2004, we were the first electric vehicle to reach 341 miles per hour. And then this was with the battery from the Toyota Prius. And then we put a fuel cell into the vehicle and we went also 300 miles per hour. Then we put lithium-ion battery and we built this other crazy monster here and we went 341. So I joined the team, in the last vehicle, but they have a long history here of attempting high-speed records. So the vehicle is very complicated. It has a bunch of battery inside, many electric machine, power electronics, gears, all kinds of things. And I won't, go into detail. If you have a question, we can for sure look at this. But what I want to tell you is that the vehicle is almost 8,000 pounds, of which almost half of it is batteries. So it's a gigantic, let's say, mass of batteries. And then there are many other things for sure, but batteries is like 45% of the overall weight. And what we were talking before about the pencil effect for light vehicle, this is not going to happen to us. Before you move 8,000 pounds, it takes quite a bit of, let's say, effort there. And this is us on Bonneville Salt Flat. This was probably 2016. It's written here on the top. And you see me over here. There are some of the people from the Venturi, that is the company that was sponsoring. This is the driver. Of course, we need a professional driver to drive this monster. There are many students here and some of the researchers that work with us. So this is part of the team of that year. And I have now a video, and I would say in advance, these videos are not done by OSU, they are done by the company. So they are a little bit over the top, a little bit, they are very fancy. So this is not to brag, but they are, let's say, a little bit too, from my point of view, they could be a little bit more simple and representing the real world experience, but I will shut up. Okay. Can you hear the noise? Oh, okay. Probably yes.
No.
Oh, no? Okay. How do I do that? Let me see. Maybe. Let's see now.
Yeah.
Okay, perfect. So let me start.
Well, I heard it for a minute. No, can't hear it now.
Oh, Let me do this. Okay, I may start. Now?
Still no noise.
We may be, I don't know how to do it, so you watch the video.
Team has achieved today a fantastic performance, 495 kilometers per hour average. That's a world record. That's really amazing. I'm extremely pleased. So I wanted to thank everybody, and we're ready to come back again here in Bonneville to go faster, I'm sure.
Okay, this was a little bit part of the, the understanding of what we do here at OSU. And I think this is all for today. And I will be happy to take any question here. And sorry
Sure.
for the video, but unfortunately it did not work out. I think if I had a few minutes, I may be able to fix it.
Oh, that's okay. Thank you so much. We're going to go ahead and let's try to see if we can make you larger. Move you up. Does anyone have any questions they wanted to ask?
No.
Yes, go ahead.
There is a record of some federal vehicles catching on fire. What causes that? What's the problem?
So his question was, there was a record of Tesla vehicles catching on fire. What was the cause of that?
So there are several. That's not the only one. As I can tell you that there are several combustion engine cars that catch on fire. The electric vehicle now are making a lot of advertisement. Of course, we need to develop car and vehicles that does not matter if it's electric or combustion engine. All the vehicles need to be safe. Many of the failure in a traditional is in a battery electric car is due to the battery. The fire is due to the battery. The cause can be a lot of things. The cause can be due to bad design of the battery pack, or could be depending on how the, if there is an accident, how the accident has mechanically has been interjecting with the battery itself. But let's say 95% of the time, the cause is battery, like in a combustion engine, the cause is fuel of the fire itself. Where that comes from, it depends on the, on the design of the vehicle itself. NHTSA, that is the National Highway Transit Safety Administration, that is located here in Ohio, and is the only office actually that from the Department of Transportation is allowed to do, is in charge of verifying these things. They follow up on every one of these accidents, and depending on the specific fault, the company needs to develop specific measures and remedies to correct their design, if any. Like, there are recalls on transmissions, on other kind of things for combustion engine vehicles. There are also recalls for electric vehicle. But yes, there is the possibility of fire hazard with lithium-ion batteries.
Thank you. Any other questions? No? All right, I think those were all the questions. Sorry, I think that was all the questions we had. Thank you so much for your time. We appreciate you sharing your knowledge with us as well.
Absolutely, it's been a pleasure.
I think you're muted.
Oh,
Yes, we appreciate it.
okay, can you hear me now? Okay.